Hi, today I'm gonna be explaining this little project that we've made. We decided to make it out of drawing. So here is our little info where we have a dryer and 4 buttons. If we click on the first one, which is drying, we have a little description of how drying consists, which is a transfer of steam or the removal of moisture from a wet solid to the surrounding, and this mechanism is made by the heat transfer and transfer of matter. And then the second button is the applications. They're pretty used for conferring certain properties to a material, to preserve certain products, or to facilitate the subsequent handling of the product, and also for reduction of transport and distribution costs. We have two kinds. First, the evaporation. If we click on this button, we have a little description of how the vapor pressure of the moisture of the surface of this solid is equal to the atmospheric pressure, so it tends to evaporate the water. And the second one, vaporization, which is carried out by convection, passing hot water air over the product. So the third button consists on the types. We're gonna be talking about direct dryers, and these two are the general operating characteristics, which are the direct contact between hot gases and solids, and these kind of variations of temperature. So we have 5 buttons of 5 different equipments used to dry. The first one is the trays. So the trays are pretty simple and pretty common actually. We have a little description over here and then the diagram, which you have an inlet of air, then you heat it up, and with a fan you distribute it all over your surface until it goes out. The direct one, it's pretty easy because you just keep a continuous transfer sieve and you blow hot air through it. So you just warm your air here and you just blow it over low. So the third one is spraying, and these must be atomized by this equipment. So you heat it and then you atomized. The fluid bed is pretty common because the solids are fluid in a stationary tank, and you may also have indirect heat coils, so this is pretty warm. And the rotating one, which is a dryer, which consists in a hollow cylinder, and it usually rotates on its axis. The thing of this is the slight inclination you have to have on the outlet, so the material can go out, and this is carried by contact with the hot gases on the countercurrent of the flow. Okay, so if we click on the next button, we have the problem. It goes over here and we have the button of the description of the problem that I'm gonna read it for you. And it says, you want to dry a wet material containing 60% solids and 40% water. Using a drying and working continuously, the wet material is fed to a dryer at 100 km per hour. Of a product with 10% of humidity is obtained. To dry the wet material, dry air is introduced into the dryer by a 70 cm inner diameter duct, and the air enters at a speed of 60 km per hour with this particular pressure and temperature. So you have to determine the amount of wet material entering through the dryer, the evaporated water in kilogram per hour, and the amount of air in kilogram water of dry air at the exit of our dryer. And here we have our little diagram and our balance button.
Here is the simulation of the problem we want to resolve. First, we have the general balance. Then we have the components balanced by solids and by water. Also, we have additional information like the continuity equation, the equation of ideal gases, and the equation for circle area. First, we will introduce the information that is already provided in the problem. For the wet material current, we have a 60% composition of solids and 40% of composition in water. For dry material current, we have the mass and we have the composition in water. So the composition in solid will be 1 minus that composition. So now we have the information to resolve the first subsection with the formula here provided. Also now we have the information to obtain the second sub. Now we need to know the amount of evaporated water. So here is the evaporated water. In order to obtain the following information, we will convert some data to proper units. Now that we have all the information in proper units, we will proceed to first calculate the area with the equation of the circle area. And now we will calculate the density with the equation of ideal gases. Now that we have all the information, we will calculate the dry air current using the continuity equation. So now we can obtain the mass of the wet air current with the information here provided. And finally, we can calculate the humidity in air uh, of the outlet in the dryer with the last equation that we have here, using the evaporated water that we already calculate and the mass in the wet air current. And this is how we calculate our problem.